Welcome to Vertica Girl. In part 1, I told you we would get into segmented and unsegmented projections. Let's review it. It's basically how Vertica splits the data across the nodes and when it copies a whole table to every node instead. You're getting there. But however, it doesn't make sense until you understand the one thing sitting underneath all of it. What is it called? The projection. Because in Vertica, when your application queries a table, it isn't reading a table at all. Your application would just see a normal table. You write a SQL against it exactly like how you would do with any other database. But that table is just a logical view. It's not where your data actually lives. The real data lives in a projection. A projection is a physical copy of your table's columns, which is sorted, encoded, and compressed for speed. We'll get to encoding later. And that projections data is physically written to ROS, the read optimized store that we reviewed it in part 1. ROS is basically an optimized, read-oriented, on-disk structure organized by projection. So the chain is pretty simple. The table is a logical view, the projection is the optimized physical copy, and ROS is where the copy actually sits on the disk. And one table can have several projections, each stored in a different sort order in its own ROS, tuned for a different kind of query. Projection A, it can be sorted by date and is built for date range queries. Projection B, sorted by customer and it is built for customer lookups. Same data arranged in different ways, each optimized for different access pattern. So next comes the question, which projection does a query choose? And the good thing is you don't choose it. Vertica does choose it automatically. When your query contains a filter against date, the optimizer automatically routes the query to the projection A because it's the one sorted by date and it can answer fastest. You just write the SQL query. Vertica picks the best physical copy every single time. So the key takeaway is a projection is a physical storage of your table's data and that data lives in ROS optimized for fast reads. Multiple projections give you different sort orders and different optimizations, and Vertica's optimizer automatically picks one for every query. That's the foundation. Next, we'll review segmented projections, which is basically where Vertica splits the data across the nodes in the cluster. So Vertica creates a buddy projection, which is basically an identical copy of A. Here is the trick. It shifts every segment one node over. The copy of A1 lands on node 2 and node 2's copy moves to node 3 and node 3's copy wraps around to node 1. Same data offset by one node. So no copy ever sits on the node that holds the original. Now put both projections together and look at each node. Node 1 has its original A1 plus A3 from its buddy. Node 2 has A2 plus A1 from its buddy. Node 3 has A3 plus A2 from its buddy. Follow any single segment. A1 lives on node 1 and node 2, A2 lives on node 2 and node 3, and A3 lives on node 3 and node 1. So every segment exists on two different nodes. So if any node fails, its data is still safe on another. Nothing is lost. That's a buddy projection. One duplicate offset by a node and your database survives a node failure without losing the data. Now let's review unsegmented projections, also called as replicated projections. And for small tables, it's the smarter move. Take a small table, a product lookups table. It just has few rows. Instead of splitting it across the cluster, Vertica copies the whole thing to every node. That's called an unsegmented or replicated projection. The entire table is everywhere. So node 1 has the complete products table, so does node 2 and so does node 3. So every node holds an identical full copy of data, and that would be wasteful for a bigger table but useful for a smaller one. Why? Because when a query joins against products, every node already has the whole table sitting right there. So no shuffling data across the network to line up the join. So it runs locally and it runs fast. That's the real reason you replicate small dimensions tables. Let's say you write a query which involves a join with the products table. Every node already has the whole table sitting right there. So no shuffling of data across the network to line up the join and return the results to the user. So it basically runs locally, so it runs faster. That's the real reason you replicate small dimension tables. And the second advantage is it doubles as your safety net, because every node already holds a full copy. So those copies act as buddies for each other. The replication is the redundancy, and a replicated table is K-safe for free. And the recovery is dead simple. Say node 2 fails and comes back online. It doesn't have to reassemble anything from the scattered pieces. It just pulls the full product table from the healthy neighbor and it's whole again. One clean copy and you're done. So here is the rule of thumb. Big tables, segment them and spread the load. Small tables, replicate them so every node has a full copy. That closes the segmented versus unsegmented loop. I hope everyone got a clear picture. If you found it useful, please do like, share, subscribe and hit that bell icon for regular updates. See you soon. Thank you.